Alright, you guys, we are back here. Now we're looking at section 9.3 for geometry. This is composite figures. Remember, to compose means to piece together or to put together. That's my definition. I didn't really look it up from Webster, but when you're talking about a composer brings a lot of instruments together, a composition brings a lot of thoughts and words together. To compose is to bring together. Easiest way to think of that is think of what it means to decompose. That means to pull apart, to break down. So we're doing the opposite of that. We're putting things together. Well, looking at this shape, it's actually got an interesting outline silhouette here. It almost looks something like a sphinx statue, whatever. But it noticeably splits it up into two shapes that are a lot easier to calculate, that we can do in pieces. So the first part it does is look at the triangle. So the triangle is calculated here. Then it says, well, this is a parallelogram. And then it asks, or shows how to find the area of the parallelogram. Then you add the two together, you get the total. That's what we're going to be doing. And by the way, if you're still looking for where this is, it's in the review section, chapter 9, page 641. Let's start with this one. What shapes do you see? I see a triangle. And the area of a triangle equals 1/2 base times height. Then I see a semicircle, and the area of a semicircle is half the area of a circle, which equals half the area of what a normal circle is, which is pi r squared. So we need to know what the radius is in order to calculate that one. Let's start out with the triangle. Super easy. Our height here is 15, and our base is 15. So it's just 1/2 15 times 15. Well, 15 squared, that's 225. So I'm going to take 225 times 1/2. I'm going to go ahead and leave that as 225 over 2. If I wanted to do in decimal form, I'd divide 2 into that, and that would give me, let's see, 112.5 if I needed to. I don't have to, but I could. And it's, of course, feet squared because we have units feet, and now we're talking about area. Area of the semicircle, let's change colors just to keep track of what we're doing here. Again, this is 1/2 the area of the whole circle, which is 1/2 pi r squared. Well, in order to do that, I need to figure out what is r. Well, if the whole thing's 15, then what's half of that? That would be 7.5, or 15 over 2. I'm actually going to use the fraction form because that's a little bit easier to square. So let's program that in here and plug it in. We got 1/2 times pi times the radius squared. Why is this 1/2 in there? Because it's half of a circle, just to remind you. Well, this is 15 over 2. And let's simplify that a little bit. 15 squared is going to be 225. 2 squared on the bottom is going to be 4. So that means I have 1/2 times pi times 225 over 4. If I were to simplify that just a little bit more, it'd be 225 pi over 8. I need to put together because I have the area of a triangle and I have the area of the semicircle. Put them together. The total area is going to be equal to 225 pi over 8. That's the semicircle. Plus the area of the triangle, which is 225 over 2. I'm just going to leave those in fraction form like that. If I wanted to figure out the actual calculation, I could use a calculator, but I don't really need to. It's not necessary. And of course, these are feet squared. That's our units. Let's try another one. Another composite figure here, looking at number 19. There's a lot of ways that we can do this. The easiest way well, not necessarily the easiest way, just the way I'm going to do it. I'm going to split it up into a little rectangle, a medium rectangle, and a big rectangle. Well, in order to figure out these pieces for each rectangle, I need to figure out these measurements for the base and height of each one. Well, this first one down here, it's just 6 and 8. That's easy. That's 48. This one up here, I don't know what this last one is, but I could probably figure it out. I know that this is 6, and then the next one is 6, and that the whole thing is 18. So then this last one also has to be 6. So this right here, 6 times 4, is going to be 24 centimeters. Now this down here, what's this base? Well, I know that this piece is 6, and I know that it continues on here. Oh wait, that's the same as this one up there. That's 4. So if that's 6 and 4, that means this must be 10, because it's got to be the same on top and bottom. So then I have to do 10 times 18 centimeters, and that gives me 180. This is a piece of cake. I just got to add these three together. The total is going to be 48 plus 180 plus 24. And of course we're looking at centimeters squared here, because our units are centimeters and we're looking at area, the total area. Well, let's simplify that just to add these pieces together. 48 and 24, if I put those two things together, I'm going to get 72 plus 180. Then I add those two together, and I'm going to get 152 centimeters squared. There's my area. Piece of cake. Let's wrap this up with one more. Probably the most challenging one of the night. That's okay, because we are awesome. Notice something, it's very subtle, but you see these little red marks all throughout. That means it's an equilateral triangle, and one of my favorite things to do with an equilateral triangle is to split it into two special right triangles. So now I have two special right triangles. Why would I want to do that? Well, when I'm looking at this, I don't see a weird hook looking star shape, whatever you would call it. I see a triangle. Whoops, let's take that one back. I see a triangle, but I need to flip it upside down. Whoa, don't want to move that. There we go. I want to flip this upside down. And I also see a semicircle on the inside of it. Probably about that size. The only difference between what I'm doing here and what's in this shape is that I'm piecing it apart. I'm decomposing it, because I'm trying to have this as my negative area, and this is my positive area in the blue. And when I take this blue piece and I cut that negative part out, that's going to give me the leftover of what I need, this gray shaded region. But that's going to help because I know how to find this semicircle, I know how to find the triangle. If only I knew the base and height. Well, if I look at it, the whole thing is, well, let's see, we got 2 here, and then the middle piece is 4, and then that's 2. Then that means this whole side here is 8 millimeters, and this side is 8 millimeters, and this whole side is 8. What does that mean that this half of it is? Well, that's got to be 4 millimeters. If I split this exactly in half, that means 2 with this 2, that makes 4, 2 with this 2, that makes 4 as well. Then the question is, what's the height of this rectangle or triangle that we're looking at? Well, if it's a 30, 60, 90 triangle, it means we have x, 2x, and x root 3 on the long leg. That long leg is going to be 4, or short leg, times the square root of 3. 4 root 3. So the area of this triangle is 1/2 base times height, which equals 1/2 of 4 times 4 root 3. I'm running out of space. I thought I could fit it in here, but that's okay. That means I'm going to have 2 times 4 root 3. In the end, I'm going to get 8 root 3 is the area of that triangle. Then I also want to find the area of the semicircle. Well, the area of a semicircle, is equal to half the area of a circle, a full circle. Well, then let's figure out what that would be. That would be half pi times the radius squared. And that half is there because it's half of the circle. What's the radius, though? That's really the question I need to figure out. So I'm going to square it. Well, if the diameter here is 4, then that means the radius, or half of it, is 2. And so is this radius. That's 2. So I'm going to plug in 2 for my radius here. Let's see what I get. 1/2 times pi times 4, because 2 squared is 4. The 2 and the 4 reduced to 2 over 1. So we got 2 pi for the semicircle. So that's our negative area. So we got to start with 8√3. And our total area is going to be the triangle minus the semicircle. So it's going to be 8√3 minus 2 pi. Now again, I could plug that into a calculator. I don't really care because I know that I did it right. And if I were to go back and check my work, I know that I would have it right. That's all for this video. Go ahead and check out the second part of it where we look at the coordinate plane.